we've got airflows, we've got reactivation heat, and we've set one of the safeties. At this point, what we want to do is allow the system to run for roughly 20 to 30 minutes to start letting the desiccant wheel rotate and start to perform. We perform a quality assurance, we perform a performance test on every piece of equipment before it ships, including the hundreds of compacts that we sell every year. So this unit is no different. We are going to take a baseline reading. In this situation, we're going to take our Visala temperature and humidity meter. We are going to record the temperature and the grains in the shop right now as it currently is, and that's going to be our baseline. So in this situation, it's a warm September day, relatively dry outside. We've got 78.7 degrees Fahrenheit at roughly 63, 62 grains per pound. So we would normally let this stabilize for a little bit, but we will record this data, and then at that point we would log it into our performance evaluation software. And again, after 20 or 30 minutes, we're going to come back to this unit and we're going to put the sensor in the process outlet, which therefore will indicate the moisture reduction that we're looking for. So now that the system's been running for 20 or 30 minutes, we want to compare the baseline performance numbers of that against our performance analysis software. And so we're going to stick this temperature and humidity probe in the process outlet, and we're going to let it stabilize there for a couple of minutes. But you will immediately see a temperature increase followed by a significant reduction in grains leaving. Typically we allow this to stabilize for 5 to 10 minutes on average. What we'll do is we'll press this hold button, which will capture the temperature and humidity in its current state. So we'll let it stabilize. I think it was in the mid-20s. Once it's stabilized, we'll press the hold button, which will capture the current data. And at this point, this will log that and it will hold it no matter where the sensor goes. And we're at roughly 120 degrees at 25 grains per pound. We'll then take that information that we receive from the baseline temperature and humidity, we'll log it into our desiccant wheel calculation software and perform an analysis of what it should be based on our simulations and compare it to our real world readings. Now, this unit will not ship if our performance does not meet or exceed that of our simulation software. So in this case, we're going in at roughly 65 grains, down to 25. That's on par with what we would expect in this environment. This unit's only been running for maybe 20 minutes, but roughly moving forward, if you let it stabilize, it will get down to the recommended drop that we're looking for.